Hello, everybody, and welcome to the Exponents edition of our GMAT Ninja Quant video series. Hopefully, you've had the opportunity to watch our arithmetic and algebra and geometry videos as well. If you haven't, be sure to check out those videos. But with that said, I want to go ahead and dive right in. First thing I want to talk about is whether this video is for you. This video could be for you for several reasons. I'll go through these here. The first one is this video is for you if you don't know where to start on exponents questions. If when you see exponents questions, you just look at them, you say, I know that's an exponent, but I don't know where to start. This video will be helpful for you. Secondly, if you know all the rules, but you still struggle, then this video will be helpful for you. You say, I know everything. I know all the rules that go into exponents, but I still have a hard time with it. Well, then this video will be very helpful for you. Second to last, if you lack efficiency or flexibility when it comes to applying exponent rules, then this video should be helpful for you. And lastly, if you are looking for a challenge, this video will be helpful for you. And the reason I say that is that we'll start out this video with a couple questions that cover the basics of exponents. But by the time we get to the end of this video, and even in the middle, we'll get into some pretty brutal problems that are pretty challenging. And so if you're shooting for, a 47-ish on quant, then even if you find yourself struggling a lot as we get to the middle and the end of this video, then you're probably in okay shape. We're going to get into some 48, 49, 50, 51 level quant questions that are going to be very challenging. And even then, even if you're scoring in that range, these types of questions you're not going to see very often. So I just want to forewarn you that we are going to get into some harder stuff towards the middle and the end of the video. So don't freak out if you're struggling or find it a bit challenging. In this video, what we'll cover is we'll go through exponents, we'll go through quadratics. Quadratics obviously are closely related to exponents. We'll talk about base conversion, factoring exponents, negative and fractional exponents as well. We'll cover those and roots. One thing I want to say before we get into too much content together here is that this video, we're not necessarily going to go over the basics of exponent rules. So I'm going to throw up here on the board real quickly a few different things. And if any of these things that I throw up here on the board don't look familiar to you, or as I put these up here, you say, well, I didn't know that, then it's probably worth checking out the link or links in the description and reading some of those articles, checking out that information, making sure that you're familiar with the basics of exponents, because we're not going to cover that. So some things that you should know, you should know that x to the 0th is equal to 1. You should know that x to the negative first is equal to 1 over x. You should know that x to the negative second is equal to 1 over x squared. And you should know that x to the 1/2 is equal to the square root of x. If any of that seems completely foreign to you, then this video may get into some topics that are too advanced for you. So go back, study this, and then come back to this video, and we'll give you some questions, and then get into some really challenging questions towards the end of this video. In any case, I want to go ahead and I'm going to dive into the first question with you. What we'll do is that I'll put this question up on the screen, and then after we've had the opportunity to put this question up on the screen, you've had an opportunity to work through it. We'll talk through it together. So here it is. Awesome. So hopefully you've had a second to work through this one. And if not, you can go ahead and pause right here before we dive into the explanation for this question. But this first one is really fairly easy. It's pretty straightforward, but it's got a lot of simple exponent rules kind of folded into it, which makes it a good GMAT question because that's what the test likes to do. I'm going to go ahead and look at it, this one on the board together. And you'll notice the question asks if the cubed root, if the third root of 9 to the 6th is equal to 3 to the negative 6x times 9 to the 5th, what is the value of x? So the first thing that I'm going to do when I see this question is I'm going to start to rewrite it. I'm going to write it in a way that maybe will be a little bit more helpful to me with my, that's going to help me kind of sort through it. I know that the cubed root of 9 is going to be 9 to the 1/3. And I know that because I know that 9 to the 1/2 is going to be the square root of 9. 9 to the 1/3 is going to be the cube root of 9. 9 to the 1/4 is going to be the fourth root of 9. So 9 to the 1/3, I'm going to rewrite it like that. And that whole thing to the 6th is then equal to 3 to the negative 6x times, and I'm going to rewrite 9 on this side as 3 squared to the 5th. So here what I have is I'm going to start to simplify here. Now there's several different ways that you can simplify it, a lot of different orders that you can do things. On the left side here, I'm going to go ahead and I'm going to multiply these exponents. I'm going to multiply 6 by 1/3, which is going to give me 2. So I'm going to have 9 squared on my left-hand side is equal to 3 to the negative 6x times 3 to the 10th. Now, a pretty common mistake that we'll see is that people are very quick to simplify something like 9 and make 9 3 to the 3rd. So you're going to want to make sure that you make 9 3 squared to the 5th here. And then I have a couple different options for how I could solve this. I could make this 3 squared. I can call this 3 to the 4th on my left-hand side. And then I can combine these two. And what I could say is this, is I could say that on my right-hand side, I know that 3 to the negative 6x, and then because I'm multiplying these, I'm going to add the exponents, plus 10 is equal to 3 to the 4th. I also could have divided things. There's a lot of different options, a lot of different ways for me to solve here. But what I'm going to get then is that I know that these two exponents, because the bases are equal, the two exponents are going to have to be equal. So I can say that 4 is equal to negative 6x plus 10. From here, I can subtract 10 from each side. I'm going to get that negative 6 is equal to negative 6x. And from here, I know that x is equal to 1. And so C is going to be the right answer here. But the main thing on this one is this is just a bunch of basic exponent rules tacked together. You can see how once you just kind of combine all those rules into the same problem, then the problem can start to feel a little bit difficult. But it's not all that difficult. Just take it step by step, break it down. With that in mind, let's take a look at the next question here. Awesome. Hopefully you've had a chance to work through this one, and we'll start to talk through it together. But again, this is another one where a bunch of basic exponent rules kind of all tossed into the same question quickly becomes pretty challenging. So we'll talk through how to do this together, and we'll talk through it on the board. And one note as we talk through this together, there are a million different ways to start to approach this problem. And I'll show you one approach, but there's a lot of different approaches. One thing that I'm going to notice right away when I look at my answer choices is that they all have some factor of 3 in them, but it's not like they all have the same base. You know, if they all had 1/3 in them, then I'd try and make everything look like 1/3. If they all had, 1/9 or 3 in them, then I'd try and make everything look like that. So I'm not necessarily going for any specific form of an answer right away, because the answer choices don't give me any sort of information as it relates to that. So I'm just going to start to simplify. And as I start to rewrite this, I remember that 1/3, that's really 3 to the negative first. And what that means is that my first term here is going to be 3 to the negative first, all of that to the negative sixth. My second term, now if 3 to the negative first is 1/3, then I know that 3 to the negative second is going to be 1/3 squared, or 1/9. So I'm going to call that 1/9 term 3 to the negative second. Finally, with my third term, 1/27, just like I'm able to figure out that 1/3 is 3 to the negative first, and 1/9 is 3 to the negative second. My third term is going to be 3 to the negative third. Okay, and I'm going to make sure that I carry over my exponents here. Remember that this 1/9 is raised to the negative third, and that this 1/27 is raised to the negative second. With all that in mind here, I'm going to start to simplify things. Now remember, when I take a power inside the parentheses raised to another power, and what I'm going to do is I'm going to multiply. So I'm going to have 3 to the sixth, then again 3 to the negative 2 times negative 3, which is again going to be 3 to the sixth. Then here, 3 to the negative 3 times negative 2, which is again 3 to the sixth. And what I'm going to get is that all of that, I'm going to add these exponents here. And when I simplify, I get my answer as 3 to the 18th. Now, that's nice. I have an answer here. The problem is that this looks nothing like any of these. In fact, the one it looks the most like is E, but I know that I can eliminate E because 3 to the 18th and 3 to the 216th are pretty far off. But now the question becomes, can I make it look like any of these other 4 answer choices, A through D? And what I'm going to notice is that all of them are 1 over something, right? So what I'm going to do is I'm going to, instead of making this 3 to the 18th, I'm going to say that 3 to the 18th is equal to 3 to the negative first to the negative 18th. Why? Because I know that if I multiply my exponents here, -1 times -18, that's going to be 18. So I can rewrite this one as 3 to the negative first to the negative 18th. And what I'm going to get then is that I have 1/3 to the 18th. So 1/3 to the 18th is another way that I can write 3 to the, I'm sorry, 1/3, don't forget your negative here. Don't make sloppy, careless mistakes. If you did make a sloppy, careless mistake, go back, watch the arithmetic version where we talk about 4 steps to follow. We're going to say 1/3 to the negative 18th, not 1/3 to the 18th. 1/3 to the negative 18th is equal to 3 to the 18th. And that is, and I'm just going to quickly cross-reference my answer choices. And 1/3 to the negative 6, okay, that doesn't work. 1/3 to the negative 12th, okay, that doesn't work. So I'm able to eliminate A and B here. I'm able to eliminate E, and now I'm down to C or D. So what I'm going to do is I'm going to rewrite this another way. Because remember, I said that 1/9 is 3 to the negative second. So how I'm going to rewrite this time is I'm going to say, okay, 3 to the 18th is equal to 3 to the negative second, and then I'm going to raise that whole thing to the negative 9th. Now, when I raise that whole thing to the negative 9th, then what that's going to do is I'm going to multiply my -9 times my -2, and that's the same as 3 to the 18th, right? So I'm going to rewrite 3 to the -2 as 1/9, and I raise that whole thing to the -9th. Now, again, what you're going to see is that this is 1/9 to the -9th. That's actually equal to C, and so C is the right answer here. Real quickly, I'm just going to go through how I could simplify this 3 to the 18th with 1/27, because just for the sake of doing it, in case the answer choice had happened to be D. So what I would do is I could say 3 to the 18th is equal to, and again, rather than doing 3 to the -2 to get 1/27, I'm going to do 3 to the -3rd to get 1/27, and then I'm going to multiply -3 times -6 to get 18, so it's going to be 1/27 to the -6. And that's why, of course, D is wrong. 1/27 to the -3rd doesn't work, but 1/9 to the -9th does work, and so C is the correct answer choice here. So a lot of good takeaways here. Number one, again, seemingly complex problem, really just a combination of many different basic exponents rules that you're probably familiar with. The other one's this, is that, just the important way to approach these problems is just to take it step by step. Don't panic. Just take it one step at a time, and make sure that you're not making any sloppy or careless mistakes along the way, like I almost did there as well. So anyway, a couple good takeaways from that one here. I'd like to go ahead and take a look at another one here, and I'll give you some time to work through it. Then we'll come back and talk about it together. Wonderful. So hopefully you've had a second to work through this one. We'll go ahead and take a look at it together on the board. So the question asks, if 4 to the 5th plus 4 to the 5th plus 4 to the 5th plus 4 to the 5th is equal to 64 to the x, what is the value of x? So when I look at this question, the first thing that comes to mind is I'm going to think about what's the best approach. Now, obviously, the math here is going to be very challenging. And this is one of those questions where kind of the first, there's not necessarily, if you're unfamiliar with this, if you've seen something like this before, you may know what to do. But if you haven't, you may ask yourself, well, how do I know what to do here? And oftentimes, you don't know exactly what the best next step is, but you'll ask yourself, well, what can I do? And what I notice is what I can do is I could factor out 4 to the 5th. If I factor out 4 to the 5th from my left-hand side, what I'm going to get is I'm going to get 4 to the 5th times 1 plus 1 plus 1 plus 1. And that is all equal to 64 to the x. From here, obviously, these 4 ones are going to add together and be equal to 4. I'm going to have 4 to the 5th times 4, which is, of course, 4 to the 6th. And that's equal to 64 to the x. What I'm going to do here is I'm going to reduce my 64 to the x. I know that 64 is 4 times 16, or 4 cubed. So I'm going to rewrite this as 4 cubed to the x, or 4 to the 3x, and I know that that is all equal to 4 to the 6th. If I know that 4 to the 6th is equal to 4 to the 3x, then I can say that 6 is equal to 3x. I can divide both sides by 3, and I can get that x is equal to 2. And A is going to be the right answer choice here. So, quick takeaway on this one, you're just going to want to factor at the beginning of this. If it's not immediately apparent to you, okay, what can I do? What can I do to simplify this? What can I do to look at this in another way? And hopefully if I start to look at it in another way, so another path forward will become a little bit more apparent. Let's go ahead and take a look at this next question together. Again, I'll give you a second to work through it, and then we'll talk about it. Okay, so this one is really challenging, but hopefully you've had a chance to work through it. If you weren't able to come to a solution, we'll take a second and we'll talk through it together here. Let's go ahead and look at this one on the board. The question says, if a is a positive integer, which of the following is equal to negative 4 to the a to the negative 4th plus negative 2 to the 4th to the negative 2a. So pretty challenging from the get-go here, but the best steps from the get-go are just to start reducing. Obviously, I see that all of my answer choices, one thing that I just kind of noticed, all of my answer choices are in some sort of base 2. So I'm going to keep that in mind as I'm working through here, that, you know, I probably want to arrive at something that's in base 2. We saw one earlier where all the answer choices didn't have the same base, so it wasn't very helpful. But here I just kind of glance and they're all in base 2. Okay, so that could be something that's helpful to know as I go throughout this problem. But first thing I'm going to do as I look at this one is I'm going to look at negative 4 to the a. And well, a couple things stick out to me. First of all is the base 4. So I'm going to go ahead and right away, I'm going to think of that 4 as 2 squared. So I'm going to call it negative 2 squared to the a. And then that whole thing raised to the negative 4th plus negative 2 to the 4, and that whole thing raised to the negative 2a. And one of the things that I'm going to have to keep track of here are my negatives. The negatives can get pretty confusing pretty quickly if I don't kind of keep track of and remember what I'm doing. For example, right here with this one, I'm actually not raising negative 4 to the a. What I'm raising is I'm raising 4 to the a, and then I'm tacking a negative. The reason that we would say that is, you know, that we're using, you know, it's not, if I wanted to raise all of negative 4 to the a, I would write it like that, you know, but this is 4 to the a in the negative version of whatever you get when you get 4 to the a. That's just order of operations, PEMDAS, exponents before you do multiplication, right? So anyway, when we think about this here, when we think about this question here. So I can rewrite, I'm going to start working on this term for a little bit here. I can rewrite this as negative 2 to the 2a, and then that whole thing to the negative fourth. Well, I can rewrite that as 1 over negative 2 to the 2a. And again, I'm going to take this whole thing to the fourth. And I write it like that just so that I can notice something here. When I take this whole term, 2 to the 2a, which is negative, and I raise this whole thing to the fourth, or at least has that negative sign on the front of it. When I raise that whole thing to the fourth, because it's an even power, it's going to make whatever is in here, it's going to give me a positive, right? So the negative ends up not really mattering because I'm raising it to an even power. Just like, if I take negative 3 squared and 3 squared, both the same. Why? Because I have an even power versus negative 3 cubed and 3 cubed are two different things. So what I'm going to do here is that I'm going to say, because it's going to be negative 2 to the 2a times itself 4 times, and all the negatives are going to cancel out, I can rewrite this as 1 over 2 to the 8a. And I can drop the negative because I'm raising it to an even power. With that in mind, I know that I've gotten this one pretty far simplified. So I'm going to start working on this term. And again here, I've got kind of that same issue where I do 2 to the fourth, make it negative. But I'm also going to remember that the question asked if a is a positive integer. Well, if a is a positive integer, then what I know, or even if I just knew that a is an integer, what I know is that this power here is going to be even. The reason that I know it's going to be even is because I have a 2 in it, and a 2 times another integer, it's always going to give me an even number, right? So I know that I'm going to raise this to an even power. So again, I can rewrite this one as 1 over negative 2 to the fourth to the 2a. And again, because I'm raising all of this to an even power, 2a is going to be an even power, I can ignore the negative here. The negative is going to cancel out. I'm not ignoring it, but the negative is going to cancel out, right, as I multiply negative 2 to the fourth by itself 2a times. And again, what I'm going to get here is 1 over 2 to the 8a. Okay. So you're going to notice that I have a 1 over 2 to the 8a term here. I have a 1 over 2 to the 8a term there. I'm going to rewrite both of those as 2 to the negative 8a plus 2 to the negative 8a. What I can do now is I can factor out 2 to the negative 8a, and then on the inside of the parentheses, I'm going to have 1 plus 1, and that's going to be essentially 2 to the negative 8a times 2, or 2 to the negative 8a, and I'm going to add the exponents here, plus 1, which of course ends up being d. So this one is a very challenging problem, but it's a good one because, again, it's simple exponent rules. There's a lot of logic here, thinking through, it'd be very easy for me to get confused by the negative term here, not realize I'm raising it to an even power. So the negatives are going to kind of cancel each other out. I'm going to multiply by a negative an even number of times. It's going to give me a positive, right? And so there's a lot of little things in here that if I don't notice, it's very easy for me to fall into one of these other answer choices and miss the question entirely. So hopefully that's a helpful explanation for you. Hopefully you're able to kind of get your mind around that. What I want to do here is we're going to keep going, and we'll continue to get into some more challenging questions together. Let's go ahead and take a look at this next one. I'll give you a second to work through it, and then we'll talk about it together. Okay, hopefully you've had a second to work through this one. The question asks if a and b are integers and 5 to the a minus 5 to the a minus 2 is equal to 75 times 2 to the b, what is the value of a plus b? We'll take a look at this one on the board together. And one thing I'll say about this is that there are multiple ways to solve this particular question, but it's a little bit more efficient than others. So I will say that one of the mistakes I most commonly see students make on a question like this is that they'll rewrite it as something like, rather than 5 to the a to the minus 5 to the a minus 2, they'll rewrite it as 5 to the a minus 5 to the a over 25 or over 5 squared, right? That's a pretty common mistake that I'll see. And that's not necessarily super helpful here, because then what ends up happening is that, or super efficient either, because then what happens is you end up multiplying everything by 25 to get the 25 out of the denominator, and things get really complicated really quickly. So I want to think about this question in a little bit of a different way. I'll start with the question as it's written. 5 to the a minus 5 to the a minus 2 is equal to 75 times 2 to the b. And the way I'm going to think about this is this, that in basic definition of an exponent, what does 5 to the a mean? 5 to the a means that I'm going to multiply 5 by itself a times, right? So if a is 8, I'm going to multiply 5 by itself 8 times. If a is 12, I'm going to multiply 5 by itself 12 times. Okay. So 5 to the a means I'm going to multiply 5 by itself 8 times. 5 to the a minus 2 means I'm going to multiply 5 by itself a minus 2 times, right? So in theory, if a were 6, I'd have, 5 to the 6 minus 5 to the 4th, right, where I'd have 6 5s here, 4 5s here, right? If a was 8, I'd have 8 5s here, 6 5s here. So when I think about kind of basic definition of what really is an exponent, that kind of helps me think about the left side of this equation. I have a terms here that are 5, and I have a minus 2 terms here that are 5, right? So what I'm going to do is I'm actually going to factor out, just like if I had 6 to the 4th plus 6 squared, I would factor out 6 squared and say then I have 6 squared plus 1, right? What I'm going to do here is I'm going to do something very similar, right? I'm going to factor out the lesser of my 2 exponents. So what I'm going to do is I know that a minus 2 is definitely smaller than a. So I'm going to start by factoring out the lesser of my 2 exponents on the left-hand side. So I'm going to take out 5 to the a minus 2. Now I've got to think about what I have in this spot and what I have in this spot, right? And so in the first spot, I know that I've taken out a minus 2 5s. You know what, let's talk about the second spot first, right? Second spot, I've taken out a minus 2 5s. So how many 5s are left? I could say 0 5s are left. I took out a minus 2 5s, so 0 5s are left. So that's going to end up minus 5 to the 0th is going to end up being minus 1. Right? Now, how many 5s are left in this first spot? Well, if I started with a 5s and I took out a minus 2 5s, right, I could say that's a minus 2, right? Make sure I distribute my negative. I'm going to get a minus a plus 2, right? A's cancel. So I'm left with 2 other 5s, right? Because I took out a minus 2 5s. And I started with a 5, so I'm going to end up with 2 5s. So I have 5 squared here, right? So now all of a sudden, I have 5 to the a minus 2, and I'm going to multiply that whole thing times 25 minus 1. From here, I can simplify, of course, say 5 to the a minus 2 times 24 is equal to 75 times 2 to the b. From here, I'm going to continue to simplify. One thing that I noticed, okay, 24 has a 3 in it, 75 has a 3 in it. Okay, I can cancel those two. So I'm going to rewrite 75 as 25. I'm going to rewrite 24, taking out the 3, dividing everything by 3. Right? I'm going to rewrite it as 8. So now all of a sudden I have 5 to the a minus 2 times 8 is equal to 25 times 2 to the b. I'll rewrite that 5 to the a minus 2, and then I'm going to convert 8 to 2 cubed is equal to, and I'm going to rewrite 25 as 5 squared times 2 to the b. So from here, it's pretty simple because I know that a and b are integers, and I've got 5 to the a minus 2, all right, is going to be equal to 5 to the 2. So a minus 2 is equal to 2, right, which is going to tell me that a is equal to 4. From here, I can also look at 2 cubed is equal to 2 to the b, so b is equal to 3. So a is equal to 4, b is equal to 3. I'm going to read the question one more time because 3 and 4 are both very tempting answer choices here. It asks for what is the value of a plus b. A plus b, 4 plus 3 is going to be equal to 7. So E is the right answer choice here. But again, a few good takeaways from this one. Number one, this is another question that we've seen here, like many exponents questions. Where do I start? What's my first move? I don't see an immediate path to an answer choice. Well, okay, what can I do? I can factor, right? And oftentimes when you're dealing with exponents questions, factoring and exponents tend to come up together a lot on the GMAT. So I can factor, and then I just begin to simplify. And like I've said earlier in this video, things on the GMAT have a tendency to work out. So I just kind of work forward knowing that, okay, things on the GMAT have a tendency to work out. In all likelihood, this one's going to work out. Okay, let's go ahead and I want to take a look at another question together, and we'll sort through it. This one's a little bit more challenging, so I'll give you some time to work through it, and then we'll talk through it together on the board as well. Hopefully you've had a second to work through this one. We'll go ahead and we'll take a look at this one together on the board. The question asks if 5 to the 8x is equal to 62,500, then what is the value of 5 to the 4x minus 2? So this one's pretty challenging right away. I can notice that. But again, kind of one of the big themes of this video is what can I do, right? What can I do to simplify? How can I make things look more like what I'm trying to get to? So I'm going to rewrite this one, and I'm going to say that 5 to the 8x is equal to, and I notice I've got a 625 term there. I'm going to rewrite my 625 term as 5 to the 4th because I know that 5 to the 3rd, 125, 5 to the 4th, 625, right? And then I tack 2 zeros on there, multiply by 100, so I'm going to multiply by 10 squared. From here, what I'm going to say is I'm looking for the value of 5 to the 4x. minus 2. Now, when I think about this question, and I think about what is 5 to the 4x minus 2, I'm actually going to push the question a little bit further here. I'm going to say, okay, if I want to find out what 5 to the 4x minus 2 is, I could really say 5 to the 4x minus 2 is 5 to the 4x times 5 to the negative 2, which means really I'm just looking for something that's similar to 5 to the 4x over 25. So if I can figure out what 5 to the 4x is, then I can likely get to my answer choice. With that in mind, what I'm going to do is I'm going to actually take the square root of this entire thing, because remember, taking the square root is the same as raising everything to the 1/2. So I'm going to raise both sides here to the 1/2, right? To the 1/2 here, to the 1/2 here. And what's going to happen is on my left side, I'm going to get 5 to the 4x. On my right side, I'm going to get 5, and again, multiply the exponents of 5 squared times 10. So all of a sudden, I know that 5 to the 4x is equal to 5 squared times 10. Now, I could rewrite that as 250. I'm not going to for the time being. Instead, what I'm going to do is I'm going to say, well, my question is, what is 5 to the 4x minus 2 equal to, right? And remember, I rewrote that as 5 to the 4x over 25. Well, it just so happens now I know what 5 to the 4x is. So I can say that's going to be 5 squared times 10 over 25. 5 squared is, of course, 25, so my 25s will cancel, and I'm going to get to 10. So C is the right answer choice here. And again, the way that I got there was thinking about, okay, what can I do? And how can I make things look similar to where I want to go, right? It's, you know, when I think about taking the square root, why was I able to get there? I was able to get there because I simplified the question and said, well, really, I just need to figure out what 5 to the 4x is. I want to go ahead and we'll take a look at another one that is also challenging, and I'll give you a second to kind of take us to look through it, and then we'll talk through it together. Okay, hopefully you've had a second to work through this one, and this one is another challenging one. We'll talk through this one together, and it's a great example of how difficult some of these questions can get on the GMAT. It's worth noting as we get into some of these really difficult exponents ones that we're showing you these because there's a lot of good underlying skills here, and there's a lot of really good, takeaways, a lot of great material here. But also some of these questions that we're getting into later in this video aren't necessarily questions that you have to get right to get a decent quant score, to get in the 47, 48 range on quant. A lot of these get beyond what's really required to get to that range of a quant score. So these are really challenging. If you're struggling with them, don't necessarily be discouraged, but there are a lot of great takeaways here. So this one asks, if S is in the set of numbers consisting of all factors of n, and n is equal to 5 to the 6 minus 2 to the 6, which of the following is not in S? What I'm going to do here is this, again, I'm going to take the first thing I would like to figure out is what is n equal to. And obviously 5 to the 6 minus 2 to the 6 is going to be pretty challenging for me to sort through. That's 125 squared, right? Not one that you typically have memorized off the top of your head. So what I'm going to do is, if n is equal to 5 to the 6 minus 2 to the 6, what I notice is this is actually a difference of 2 squares, right? I could rewrite this as 5 cubed squared minus 2 cubed squared and say that n is equal to that. I could further rewrite this then, because it's a difference of 2 squares, and say that n is equal to 5 to the third plus 2 to the third times 5 to the third minus 2 to the third. 5 to the third, of course, is 125. 125 plus 8 is going to give me 133. And 125 minus 8 is going to give me 117. From here, I know that n is equal to this number. Now, I could go ahead and I could multiply all this out and try and get figured out what n is equal to. But I also know in the back of my mind, I'm going for the factors of n, right? Because those are what constitutes set S. So because I'm going for the factors of n here, I'm actually not going to multiply it all out. Instead, I'm going to think about what are the factors of 133, what are the factors of 117, because they're going to make up the factors of n. Now, this actually can be challenging for a lot of people because the first instinct that I have when I look at these is that it's like, well, 133, 117, not typical numbers, that I know really easy off the top of my head what the factors are of it. So let me show you how we go about finding the factors of one of these types of numbers, because I'll take, for example, 133. So 133, obviously I'm able to eliminate any sort of even numbers. I'm able to eliminate those right off the bat, right? So then I got to think about 1. Well, one obviously is a factor of it, but 3. Okay, well, 3 is not a factor of it because the digits add up to 7. 7 is not a multiple of 3, right? If the digits add up to a multiple of 3, then it's divisible by 3, but okay, 7. So it's not divisible by 3, which also means it's not divisible by 9. Tuck that away in the back of my mind. Think about, okay, is it divisible by, I'm just going by my odds, 5, not divisible by 5. Okay, next odd, 7. Okay, well, is 133 divisible by 7? Closest multiple of 7 I know is 140, right? 7 times 20. So 133, I could actually say that's 7 times 19. Now, in theory, for what it's worth, if I were trying to check the multiples of 133, I would only need to check up to the numbers of the next greatest square. So let me give you an example. So any number, 133, the next greatest perfect square is 144 here. And I know that 144 is equal to 12 squared, or 12 times 12 is equal to 144. So as I'm looking for factors of 133, what I know is this. I only have to check the numbers up to 12. And the reason for this is if I'm checking the numbers up to 12, okay, and let's say in theory, you may say, well, what if 19 is a factor of 133, right? Just like it is, right? 19 is a factor. How do I know that? How was I supposed to know that I was going to check this? Well, if 19 is a factor of 133, then there's also going to be a factor that's less than 12, that the corresponding factor that's less than 12, that when you multiply it is equal to 133. And the reason for that is this, is if I have two numbers that are greater than 12 that I multiply by each other, I'm not going to get something that's equal to 133. In fact, I'm going to get something that's more than 144 because 12 times 12 is 144. So just a little thought to tuck away in the back of your mind as you're looking for factors. But anyway, I get 7 and 19 here are the factors of 133. And then 117, I'm going to go through a little bit of a similar process where I'm going to think about, okay, what are some potential factors of 117? I notice right away the digits 711. Okay, that's going to add up to 9. So 117 is going to be divisible by 9. Okay, and what I'm going to do from here is this. 117, when I divide it by 9, I'm going to think, okay, 9 times 10, 90. 9 times 13 is going to give me 117. So I've got 9, 13, 7, and 19. Now these are numbers that I can work with. I could further, simplify if I'm going to really. Now I've got all primes if I'm going to really do prime factorization here, right? And now I can look at which of the following is not in the set of S, right? 3, that's in the set, right? 7, that's in the set here. 11, can't find it in the set. 39, well, if I did 3 times 13, that's going to give me 39. 91, that's another one, a little bit more challenging for a moment, but if I think about 7 times 13, that's actually going to give me 91. So 91 is also in the set. And so 11 is the only number here that's not a factor of 5 to the 6 minus 2 to the 6, whatever that number is. But a lot of opportunities here to go wrong, a lot of opportunities to be careless, sloppy, but also one where, again, factoring and exponents end up overlapping, and factoring ends up doing a lot for you as you work through it. Let's go ahead and let's take a look at another one. I'll go ahead and toss it up on the screen and we'll talk through it together. Awesome. Hopefully you've had a second to work through this one, and I want to go ahead and we'll talk through this together. The question asks, if A and B are positive, is A to the B over 2 greater than A to the 2B? We'll talk about this one on the board, and right away, one of the things that sticks out to me is that the way the question is currently phrased is A to the B over 2 greater than A to the 2B. Well, right away, I noticed that that's not really written in a form that's super helpful to me. And so what I'm going to do right away is I'm going to try and push this question, because as it stands, this is a really hard question. It's a really challenging one. And so I'm going to try and push it and see if I can make the question any easier for myself, right? So A to the B over 2, I guess I could rewrite that as the square root of A to the B, right? I could rewrite it as, before that, of course, A to the B to the 1/2, right? And then I could rewrite it as the square root of A to the B, right? And then the question is whether that's greater than, right, A to the 2B, which I could rewrite as A to the B squared, right? Or A to the B squared. And so very quickly here, I can say that I've got two quantities that I'm comparing. This is my question, of course. The square root of A to the B and A to the B squared. Now, what I'm going to do is I'm going to ask myself here, I'm going to rewrite A to the B. I'm going to say, just for the sake of just pushing the question, Okay, because I notice I'm comparing two quantities that are similar here. And so what I'm going to do is I'm going to say, okay, just to simplify this further for myself and think about this, a little bit deeper. Let's say that a to the b is equal to x. Okay, x is equal to a to b. Well, then the question becomes, is the square root of x greater than x squared? And when I think about it, I want to think about this on a number line. When is the square root of x going to be greater than x squared? But I'm also going to keep in mind, what do I know about x, right? I know because I know that a and b are both positive. I know that x is positive, right? So what I'm going to ask myself is, if I were to start my number line right here, right, and go from 0 to infinity, at what point from 0 to infinity would the square root of x be greater than x squared? Well, the square root of x would be greater than x squared whenever x falls in this range. If x is less than 1, then the square root of x is going to be greater than the square root. I'm sorry, is going to be greater than x squared, right? If x is less than 1, right? So again, another way that I could rephrase this is, where is it that the square root of x, do I know that the square root of x is greater than x squared, right? I'm going to rewrite this question and say, is x less than 1? Because again, that's where I know that the square root of x would be greater than x squared. Okay, now I'm going to take it back into the format because, again, I don't have x in either of my two statements. I'm going to continue to push this question, right? And I'm going to reframe the question as, is a to the b less than 1? And that becomes my new question. Now, for a to the b to be less than 1, well, what would have to be true for a to the b to be less than 1? Well, I know a and b are both positive, right? So as I think this through in my mind, right, I know that for a and b to be positive, if a and b are positive, the only way that a to the b is going to be less than 1 is if a is some sort of fraction, right? Because if a is greater than 1 or equal to 1, then, even if b is a fraction, right? So even if I say that a is 2 and b is 1/2, right? I'm still going to get a positive number. So again, what I'm asking myself, really, ultimately the question becomes, is a less than 1? And you can see I'm able to think through all this using logic. I don't have to guess any numbers. I can give you some examples as I'm talking through, but again, I don't have to guess numbers. I don't have to test cases. I don't have to do any of that. And all of a sudden, the question becomes really simple, because the only way that a to the b is going to be less than 1 is if a is less than 1, right? And so the question becomes, is a less than 1? And all of a sudden, my very challenging question got much less challenging. Now, it took a lot of work to get there, but that initial investment is going to all of a sudden be very helpful when I get to the statements. So when I think about statement 1 here, statement 1 tells me that 1 is less than b, which is less than b to the a. Okay, so what I'm going to do is I'm going to break this up into actually two separate inequalities here. And I'm going to say my first inequality is just these two. My second inequality is these two. So my first inequality tells me that b is greater than 1, which, good to know. My second inequality tells me this. B to the a is greater than b. And again, I flipped the signs going from here to here, but that's what these two inequalities tell me, right? If b is greater than 1 and b to the a is greater than b, what that's going to tell me, that actually gives me some information about a. Because I want you to think about this. If a is some sort of fraction, then what's going to happen is that all of a sudden b to the a is going to be like taking the square root, and it's going to b to the a would actually be smaller than b. If I'm told that b to the a is greater than b, then what I know is this, is that I know all of a sudden that I know that A is greater than 1, right? And the reason that I know that is because raising B to some positive power greater than 1 is going to make it bigger than what B originally was, right? So this first statement actually tells me that A is greater than 1. So, of course, I go back to my answer choice. That answers the question. Now, statement 2, when I look at it, statement 2 all of a sudden becomes very easy. The reason that statement 2 becomes easy is because I pushed my question. My question is asking me, is A less than 1? Statement 2 doesn't tell me anything about A, or about the value of A, right? I still know that A is positive. I still know that B is positive. I know now that B is less than A, but that still doesn't tell me whether A is less than 1. And so for that reason, I'm going to come to the conclusion that statement 1 is sufficient. So the correct answer here is going to be A. Again, that's a really challenging problem, but one where you can see that pushing the question, thinking through things logically, gets you to the right answer. Whereas if I were to just guess numbers, okay, maybe I have a shot at getting it right, maybe I don't, right? It's really just a shot in the dark. Let's go ahead, and I want to take a look at one more question, the final question of this video here. We'll go ahead and take a look at this together. Awesome. Hopefully you've had a second to work through this one. And another challenging one here to wrap up this video, but let's talk through this together on the board. So first thing that comes to mind when I see this question, to be quite honest, is estimation. When I see this question, I think it'd be really nice if I could estimate to find the answer. Then I happen to glance at the answer choices and I see estimation is actually not going to be very helpful, unfortunately. But definitely, where the answer choice is pretty far spread apart, I'd go to estimation very quickly, right? Unfortunately, on this one, estimation isn't going to help a ton. And so what I'm going to do instead is I'm going to start to simplify things the best way that I know possible. I'm going to start with the term that I have on the left here. And what I'm going to do is this, is because as I look at this question and I wrestle with it, it's pretty clear to me that the way that it's written is not really helpful. So I'm going to think about, do I have another way that I could write this question? Because as currently written, I can already tell I'm not getting anywhere. So is there another way that I can frame it? Is there another way that I can write it? It's one of those where I look at it, I say, what can I do? Well, the way it's currently written is not helping me at all. Is there another way that I can write it? And when I think about another way to write this one, what I'm going to think about is I'm going to think about taking it into using some scientific notation to try and simplify things for myself, right? Because if I can do that, then maybe I can see how some terms relate to each other. Hopefully, maybe some things will cancel. I'll just try and think through it that way. But what I'm going to do here is this: is I see that the first one is basically the first term in the numerator is basically I have 9, and then from that 9 I've taken away, I've subtracted, right? What I could say is 1 times 10 to the negative 6, right? There's 6 decimal places here that I'm going to move over. I'm going to subtract 1 times 10 to the negative 6, right? On the bottom, what I have is basically 3, and then I've added on top of that 1 times 10 to the negative 3rd. Then I come over to this term here. And again, this term here, I'm going to subtract it, but it looks most like, to me, I've got 4. And then from 4, what I've done is I've subtracted some form of the number 25, right? And so the way that I'm going to write this is I'm actually going to write it as 4 minus, I'm going to call this, what I've lost here is 0.00025, right? That's what I've subtracted from 4. So I'm going to rewrite this, and I'm going to say, well, on the one hand, 25 is kind of like 5 squared, right? That's 25. But then I've taken 25 and I've moved in the decimal place 1, 2, 3, 4, 5, 6 places to the left, right? And so I'm going to rewrite this as 25 times 10 to the negative 6, or 5 squared times 10 to the negative 6. And again, that's what I subtracted from 4, right? That's what I've lost from 4 here. So I'm going to do 4 minus 5 squared times 10 to the negative 6. And then on the bottom, in the denominator here, what I'm going to be able to do is I'm going to rewrite this one as, it's pretty close to 2. So 2 minus, and again here, I have lost 0.005. So how can I write that? Well, that's 5 times 10 to the negative 1, 2, 3, times 10 to the negative 3rd, right? So 2 minus 5 times 10 to the negative 3rd. Okay, so again, this isn't immediately helpful to me, but what I'm going to do is I'm going to continue to simplify here. And what I notice is this, is that all these numbers in the numerator are actually squares, which works out pretty well. Again, that just kind of makes me think, okay, difference of squares. GMAT loves to hide these little quadratics here and there. So let me see what I can do with the difference of squares. Right, 9 minus, I'm just going to call it 10 to the 6 because the 1 doesn't do a whole lot for me there. So 9 minus 10 to the 6. Okay, well, that's the same as 3 squared minus 10 to the negative 3rd squared, right? So I'm going to rewrite that as 3 plus 10 to the negative 3rd times 3 minus 10 to the negative 3rd. What I notice and what tells me pretty immediately that I'm on the right track is this is going to be pretty convenient. I'm going to have something in the numerator cancel with something in the denominator. Feels very GMAT-y to me. And so I'm going to go ahead and cancel the 3 plus 10 to the negative 3rd on both of these terms. And now I'm going to write 3 minus 10 to the negative 3rd is all I'm left with of this first term. I'm going to leave that as is for right now, and I'll come back to that in just a moment. But I'm going to go ahead and I'm going to simplify. And again, the numerator of this could be written as 2 squared minus 5 times 10 to the negative 3rd, and that whole thing squared. I'm going to continue, and I'm going to say that this could be written as 2 plus 5 times 10 to the negative 3rd times 2 minus 5 times 10 to the negative 3rd. All of that over 2 minus 5 times 10 to to the negative third. Once again, I know that I'm on the right track because I see here, okay, things are going to cancel. Feels very GMAT-y to me. And so I'm going to go ahead and cancel this term, the 2 minus 5 times 10 to the negative third, in my numerator and in my denominator. Both of those are going to cancel. And then what I'm left with on this side is the 2 plus 5 times 10 to the negative third. Now, remember here, very easy to forget on such a complex problem. Remember here to carry your negatives over. Remember, make sure that you're not missing any of that, because what's going to happen here is I'm going to have a minus sign there, and then I'm going to put all this in parentheses. What I'm going to get is I'm going to get 3, and that's going to be 3 minus 2, which is going to give me 1. And then I'm going to have negative 10 to the third. And then remember, I'm going to distribute this negative here. So I'm going to have a minus sign there. And what I'm going to get is negative 10 to the third minus 5 times 10 to the third. So it's going to give me minus 6 times 10 to the negative third. Okay. 6 times 10 to the negative third is going to be 0.006. 1 minus 0.006 is going to give me 0.994. And so the right answer choice here is going to be A. Hopefully that was helpful for you. And this, the principles here, rewriting things, you know, okay, it's not helpful to me in this form. Is there another way that I could write it? Is there another form that, what can I do, right? Let me push this thing a little bit further. All good takeaways. All throughout this video, hopefully this entire video has been helpful to you as we've gone through exponents. Remember that when you see exponents in problems, remember many of the basic things that we talked about in this video. You know, remember to look for quadratics. Remember to look for how you can simplify things. Make sure that you're pushing the questions, the question, all sorts of good things that we talked about throughout this video that you can apply to exponent questions. Much of the latter half of this video were very challenging exponent questions. So if you struggled with them, don't necessarily get too worried about that. They were meant to be challenging. They were meant to challenge you, and you can still get a really good quant score even if you struggled on those. But like I said, hopefully this has been helpful for you. And be sure to check out some of our other videos. And hopefully we'll see you next time. Thank you.